Okay, here's a question about a continuous random variable. We've got one of these double-barreled functions on a split domain. And the first thing we've got to do is sketch the graph of f. Now between 0 and 2, it's got this equation, and you should recognise that as a curve, and you should really know the particular kind of curve. But the other thing that you always do is you substitute in the x values at the endpoints, get two y values. So you've got two endpoints to plot, connect them with a suitably shaped curve. Then you should recognise this kind of function and what shape that graph is going to be. Once again, get the two endpoints, join them up clearly, and do try to show that outside the range 0 to 5 the value is 0, so try and show something hugging the x-axis for the rest of the time. So a curve that curves the right way, a correctly shaped other section with correct endpoints, and you should get you 3 marks here. For part B, prove that the cumulative distribution function on this particular part of the domain can be written in that form. So it's essentially a show that question. We're going to end up with this. Remember that the cumulative distribution function, this is the wrong shape for this particular one, but you get the idea. The cumulative distribution function just means all the probability up to and including the given x value. So what we're doing is we're doing an integral or integrals to find this area here. But because there are two different rules for the function, we're basically going past the changeover. So there's some kind of change in the rule for one section of graph onto the other. So what you have to do is find, firstly, all the area up to the cutoff point, which in this case is 2. So you're going to be doing an integral with limits 0 and 2. And then you're going to be doing another integral from 2 up to x, okay, of the second function, and I put dx here. Strictly speaking, we ought to do the integrals with respect to t, but you get away with doing x's. So these two integrals combined, this will come out as a number. This will come out when you put the limits in. There's an x as one of the limits, so you'll get a function of x. And then what you've got to do is make sure you express your answer in this particular form. And finally, we've got this line. This means this is a conditional probability. You've got in your formula book something that you can rearrange. The formula for probability of A and B in your formula book can be arranged into the formula for the probability of A given B, or the probability of B given A, which is a probability divided by a probability. And in this case, the probabilities will both be, once you've worked out what this actually means, it will be the probability of the x in this question being in one range divided by the probability of it being in a different range. And since you've got the PDF and the CDF, both of these values are actually within the range 2 to 5. So using the fact this f of x means the probability of x being less than or equal to any given x, you should be able to use this to work out the probability of being greater than or equal to 3, or less than or equal to 4, or between 3 and 4, or any other probabilities you might need when you set this up. So go back to first principles about what a conditional probability is, and then think about what these probabilities mean given the event A is being greater than or equal to 3 and the event B is being less than or equal to 4.